Hello, my name is Jonathan Halstutch. I'm from Racktop Systems. Today we're going to talk about VDI, and if you talk to some of your friends, they might have told you it took them months to implement VDI at their location. Well, today I'm going to show you a way that you can implement VDI to your first 80 users of your office in less than 8 hours. So let's take a look. So why do people implement VDI? Typically, they're motivated by one of three things. Almost everybody wants to save money, right? That motivates us to do most things, and we want to cut costs. If you look at VDI, the typical upfront investments are more than implementing traditional desktops. There's an increased licensing cost and a few infrastructure pieces that cost more money than in a traditional desktop approach. But the savings comes long term by reducing staff, uh, better productivity, and better manageability. Although people talk about managing more with less, you can do it with less people, but it takes a higher skilled admin. I kind of relate this to automobile work. 30 years ago, you didn't really need a computer to work on a car. You could tune a carburetor and the engine just by the ear. Nowadays, you really need a computer to be able to diagnose what's wrong with the engine, how things are working, and it takes a more skilled and advanced mechanic to be able to fix a modern car. The same is true for VDI. It takes less people, but it takes a more skilled administrator. The other big thing about VDI that users really come to love is the ability to access the desktop from anywhere and have that same desktop. And it can provide better security. All your data is in the data center. Also, if you have kind of a malware outbreak or a virus outbreak with non-persistent desktops, you're able to just log in again and get a completely refreshed desktop, as well as patch against those bad things very quickly. So let's talk about the typical journey for somebody wanting to implement VDI. Usually, in the past, when VMware came to us to talk about the Rapid Desktop program, they said it was taking 12 to 18 months to do a proof of concept. Not even go to production, but just to do a proof of concept. Most IT projects that take that long are considered failures because it takes too long and people lose interest. So we're going to talk about how to shorten that timeline and what those steps are. So first, you're going to survey your environment and see who's candidates for VDI. You're going to see what type of work they do. There's kind of the low-hanging fruit like the office automation people. The more challenging people will be people that are using 3D graphics programs, the CAD designer, things like that. Those aren't good candidates for VDI, and you got to look to see if there are somebody you want to give a virtual desktop to, or if they're better left as a traditional desktop. You're going to go into your planning phase and determine who are going to be your pilot users, who's going to be friendly to you, and then what infrastructure upgrades are required to get to the proof of concept, and then if you get beyond a proof of concept, are there further upgrades required to your infrastructure? You're going to want to choose a pilot group that is representative of the various users you plan to have in your final VDI rollout. So you want the office automation person, you want people from accounting, and that use the different programs so that you know what programs and applications can be virtualized within the desktop. And then based on the pilot, you'll do your refinement, come out with a phased rollout plan, and then get into that point where you're doing the continuous improvement patches, updates, just like you were on your traditional desktop environment. When you decide to roll out VDI, even as a proof of concept or into full production, it really has to be an upgrade to the user. If anyone's already happy with their desktop environment, they may be skeptical of the change you bring when you say thin clients or VDI. There tends to be a negative view towards VDI because it's like they're giving something away. So it really has to feel like an upgrade to the user once they get the VDI experience. And when you're rolling out VDI, you want to reduce your risk and manage your costs. You want to know how much it's going to cost up front and then be able to mitigate or eliminate any risks during the rollout. So knowing what applications people have already virtualized, for example, elsewhere that work or don't work is a good way to say, let's not go down that path or spend time or money. Also, the shorter the timeline, like I said before, people won't lose interest in a 1 week or 1 month project. A multi-year project could lose funding, it could lose interest, or people could have its doubts about whether it'll even be successful and it's the right investment. Additionally, you really don't want to have to redo or waste work you did in a proof of concept when you go to full production. So if you can take a pilot or proof of concept system and scale it all the way up to full production, you're not doing a lot of extra rework. So I would look for a solution that does that. Some things out there only scale to a certain number of users. So if you want to scale beyond that, it's kind of like you have to throw that whole solution away and start over from scratch. With VMware View and the things we're going to talk about, you're going to scale from pilot all the way to production without a problem. So there's a few technical challenges as well related to VDI. The first one that everyone kind of talks about and is pretty well known is storage. And so the amount of storage IOPS, and that comes directly from the storage solution you choose. The other pieces of it, though, are all about the whole architecture and how you decide to implement VDI, because there are a few ways you can do it, and we're going to talk about two of them today. And that affects kind of your storage, the compute, and the network. And then beyond that, once you've made your architecture decisions, you're going to have to determine how well do the applications you have in your user's environment work based on the way your users use it. So people say, try to get the user to change. That's harder, especially if you don't have any control over those users. They're in a different organization. So you need to figure out how well will the apps that you want work in a VDI environment. And then also, are you going to support bring your own device? Are you going to support people using a zero client? Are they going to use a Windows desktop? Are you going to immediately roll out zero clients in the case of VMware View? What's your kind of strategy? How flexible are you going to be with supporting those end devices? And who's going to be responsible for supporting the end devices? And that's a lot of testing and time and kind of decisions to be made after you've kind of experienced VDI. So first I'm going to talk about the storage issue, and then we're going to talk about the architecture decisions. So with VDI, virtualization, if you did server virtualization, created kind of that IO blender effect where you had a lot of different streams blended into one stream, creating this kind of random IO. Well, VDI is even worse because what VDI does is it goes from a 90% read IO to 80% write IO during different phases of a VDI desktop. So when the desktop's first booting, it's 90% reads. Then when you get into this application steady state, people have logged in, they've opened their applications, and they're starting to do work, then it goes to an 80% write. So what does that mean? That means you need to be able to handle the very dynamic swings of VDI. And you can't really just plan for best case scenarios. People will talk about, hey, during a normal operations, you only need 15 IOPS per desktop. Well, that may be true, but what if you need to reboot all the desktops during the middle of the day? Or what if the system just fails during the day because you lost power to the data center and you now need to reboot everyone's desktop? You can't afford to wait hours for all those desktops to come up because people will be unproductive for 3 days, and now you're losing part of that TCO, and you're going to have unhappy users. Also, there's certain things that just can't be handled by cache. So in particular, VMware View does a recompose when you recreate the desktops for everyone. That's very storage IO intensive and can't be escaped by just using caching. So at Racktop, we have a storage solution called Brickstore. It's based on ZFS, and the architecture is perfect for VDI because it uses hybrid storage pools that leverage the best of solid-state disk, RAM, and regular hard drives. With those three devices, you're able to get very fast random I/O with very low latency to give the user the best performance, even better performance than they would get on a traditional desktop. Hybrid storage pools are really cool from a technology point of view, and let me explain why. Your RAM acts as your level 1 cache, and we call it the adaptive replacement cache. And then your level 2 read cache and your write cache are your secondary caches, followed by your data disks, which are kind of at the bottom there. So instead of having one pipeline with just generic caching, you have a cache pipeline optimized for reads and a cache pipeline optimized for writes. What this means is you're able to take technology and use the best features of that technology to do exactly what you want to do. So in this case, we have a write cache, which is typically an SLC SSD. Why is the write cache SLC SSD? Well, SLC technologies tend to offer the lowest latency for the write, but they're more expensive. Well, less important in the read cache environment is how fast you can write to it, but rather how fast you can read from it and having a larger read capacity or total data capacity. So in our read caches, we're able to use an MLC SSD. And then for our pool, where the speed is not always as important in a high random I/O environment like with VDI, we're able to use large nearline SAS drives. So with this hybrid storage architecture, we're able to deliver very high random I/O with a lot of capacity. Instead of having to have 15K disks, we're able to use a combination of a little bit of SSD and nearline SAS drives to offer even more random I/O than you might get out of 15K SAS drives, and a more cost-effective solution. Also, you're able to offer both block and file and present that to a client from this same set or singular set of disks. So at the same time, you can be offering CIFS and NFS to the same set of disks, and you can offer a portion of that disk in block as iSCSI or fiber channel. So that's really cool and gives you a lot of flexibility both now and later as things change or you need to accommodate specific applications. So in VDI, a lot of times you're just going to stick with NFS or iSCSI, and predominantly we've seen a lot of NFS applications in the VDI environment. So here I'm going to show you how a write I/O operation happens to a hybrid storage pool. So in the top left you have the client. It's writing to the hybrid storage pool or to the data device, and it's writing data to RAM. So everything's written to RAM. Now, if that application requests a sync and wants the data to be committed to stable storage, the data actually isn't written to storage right away. What happens is a log to recreate that entry or that data is written to the ZIL. That's the SSD write cache. So a log entry is written to the ZIL. As soon as that data is written to the ZIL, a commit it's considered committed to stable storage, and an acknowledgement is sent to the client. Now, that keeps going on, and data keeps getting written. Now, every 5 seconds about, that data is committed from RAM to the disk pool. So once that data is written from RAM to the disk pool, then the log entries in the ZIL are crossed off, and this process repeats itself. It's basically like a database transaction, right? If something were to happen before that data was written from the ARC to the disk pool, the system would read the logs in the ZIL and recreate that data and write it to the disk pool. So it's very much like a database. And what happens now is this is very fast because all that data, that log entry is written to the ZIL in a very small random I/O, and the ZIL is optimized for high random I/O, low latency writes. Then, as a long sequential write, the data is written from the ARC to that disk pool. So it's basically using all the features you would expect out of those devices. So SSD, high random I/O, disk pool, spinning disk, large sequential writes. So it's grouping a bunch of small transactions into one larger transaction. Now, in a read situation, data is read, hopefully if it was recently read, it's going to try to read it from RAM. If it's not in RAM, there may be an entry to say, this is actually in our level 2 cache, the read cache, that other SSD, the L2 ARC. If it's not there, if it's been a long time, it's been evicted already from RAM or the read cache, and it's now just living in the disk pool, then the data is read from the disk. So the fastest is if it's actually being read from ARC. Second fastest is if it's being read from the read cache, and then obviously slowest would be if it's being read from the disk pool. So you can kind of see, here's what's happening. So data you just wrote to disk is most likely going to still be in the RAM, because when it did that commit operation, it doesn't delete it from RAM, it just makes a copy to the disk pool. And then before it gets flushed from RAM to the disk pool and completely evicted from RAM, it actually gets evicted into the L2 ARC. And then if there's no more room in L2 ARC or the read cache, then it's deleted, and the only place you can read it is from the disk pool. One also important note is, although it's not illustrated well on here, is that every time you read data, it's read into RAM. So the next time if you go to reread the data, you'll be reading it from RAM unless it's been evicted. So as data is read, even if it's read from SSD or from the disk pool, it's also cached in RAM as well. So what does that mean for a desktop environment? Well, most of these desktops are actually going to be looking at the same VDI or OS image. So what actually happens is it's like you're operating your desktop completely out of RAM in a lot of situations, because remember, all that data the first time it's read is read into RAM. And the next time you go to read it, it's going to be in RAM. So anytime a write operation happens, it's written to RAM. Anytime a read operation happens, it's read into RAM and to the client. So what that means is once you have one client read the information, so the first VDI session boots, the data's pushed into RAM. The next VDI session boots, it's reading all that data for RAM. So now it's like all of these VDI users are using a giant RAM disk. This will be faster than the experience they'll have on a traditional thick client. So we talked a little bit about the storage I/O problem, and now the second thing I think to consider are the two paths, which I think are the top two paths for a VDI architecture. So most of you are probably familiar with this traditional VDI architecture. You have your storage, you have your network, and you have your compute. You need to balance these and alleviate the bottleneck to get the performance you need. The second path, which I think is the ideal path in most situations and kind of has a shared nothing type architecture, is the stackable blocks. What happens here is each block on the right, if you look at the center of the screen, has a copy of the master and the link clones. Your desktop compute, your RAM, and your storage or your desktop is being presented out of that. That's where I have labeled the VBox. So each of those VBoxes has everything you need to handle a VDI user. The profiles, all the shared information like the user drive, their personal information, could be shared still on shared storage, and that's what I have over on the left. Also, the masters of that VDI desktop can be shared there, so if you ever need to recreate it or work on it, it can be manipulated from the shared storage. And all of those VBoxes have access to that shared storage. What does this mean? Less dependence on your existing infrastructure. Now, to implement VDI, you just need basically a single server that has been designed to handle VDI hosting, and users will be able to start logging in. So I'm going to get into a little bit of this. But the other part of that is the isolation. In that other approach, if we go back, you can see everything's reliant on that same network and on that single storage device. If one of those goes out, everybody's out of business. In this approach, you have isolation. If one VBox goes out, the only people that are going to be affected are the people on that VBox. They'll just simply have to log back in to another VBox. They're using non-persistent desktops, so they're going to get a fresh desktop, and they're going to be able to access their profile, which was shared to all of those VBoxes via the shared storage over on the left. So it's a less expensive POC. It takes a lot of the risks we talked about out of the equation, and it's faster to implement. So let me dive into this a little bit more. So we talked about the reliance on infrastructure. In the old traditional system scaling, you have to kind of scale compute and your storage requirement at the same time. And typically, they don't scale together. So you're constantly battling with how much compute resources you need and the storage I/O requirement and capacity while you scale up the number of users for your VDI implementation. Alternatively, consider VBox, where the solution, the storage, and the compute scale linearly together. So as you need to add more users, you just add another VBox. Entry-level VBox can handle 60 office automation users. High-end VBoxes can handle way over 100 high-end power users. So it takes the guessing game out of balancing the amount of storage I/O you need per user as well as the amount of compute. It really is an ideal way to grow your virtual desktop implementation. And it provides you the isolation and that N+1 architecture you're going to need. I already touched on some of the benefits of stackable units, but we believe so deeply in the benefit in a lot of cases of a stackable unit or the shared nothing architecture that we've developed a whole product around it, which is VBox, a VDI in a box turnkey appliance. It offers the scalability and the flexibility to drop in VDI into your existing environment without burdening a system that was working for your existing infrastructure. So a lot of people look at VDI and say, oh, well, if I want to implement that, now I have to upgrade all of that investment I just made. With something like this, you're not going to overburden your existing SAN NAS infrastructure or your network. you're also going to contain all of your users into those boxes. And that's important because I've seen instances where a single desktop can grab 1,000 IOPS from the shared storage. In this situation, a runaway desktop user is only going to affect that particular VBox. So you get that added isolation and security, that containment that I think is important in VDI. Also, with a solution like this, you can do an N plus one architecture. So you can actually have an extra box for extra capacity that allows you to take a box down for maintenance. Or if a box goes offline, you have that extra capacity standing by that people can just log back in and get that new non-persistent desktop, grab their profile from the shared storage, and be on their way again. VBox and this architecture reduces your risk to the point where it's just like buying a server purchase and in line price wise with another server purchase, as opposed to trying to figure out an entire architecture to implement VDI where you have to say, what's the network I'm going to need? What's the monolithic storage requirement I'm going to have? And what's the right compute platform? It just simplifies it to the point where you can get what takes some people 18 months to accomplish done in 8 hours. And it's that easy to say, why wouldn't you do it? VBox was actually designed to offer and deliver high performance virtual desktops, a desktop experience that was comparable or better than a traditional fat client. And at the same time, we've realized that you can deploy VDI faster using the VBox architecture than you can a traditional architecture. It leverages VMware View 5, which delivers PC over IP for the richest graphical experience. And it's app and it eliminates the problems that you've had with a traditional VDI implementation of burdening your existing infrastructure. And I can't talk about that enough, but it really is the simplest way to go from proof of concept all the way to full production. So some other ways that I would recommend, no matter which path you go to reduce your risk, is that you consider storage I/O as something that'll never go down. You're gonna need it, so get as much as you can to in parity with what you're gonna need, and go a little bit bigger and grow into it. And you know, be realistic about the ideal canvas for VDI. Start easy, and then start shaving down your more intense users, like the 3D graphics users, if possible. And use a pattern or reference design. And I think, we're offering you that here. I think this is an ideal design. We've had experience with it. You can easily get this to go from proof of concept to scaled architecture, delivering high performance VDI. And also fail fast. You don't want to be 18 months into a project to realize, hey, this just isn't going to work out. It's never going to happen for us. You want to know right away. And VBox is going to enable you to know which users you can get on your virtual desktop infrastructure right away, given today's technology. So you may not get everything right the first time, but if you do, or you're that kind of person, we are hiring, so please apply. But it's all about getting the right size, monitoring, adjusting, and validating your design, being agile and resilient, and addressing as many of the challenges in the pilot, because typically the more you can kind of flush out in the pilot, the better off you are, of course. I look forward to hearing more about your journey in the VDI environment. We also can offer you a test experience on one of our VBoxes if you want to log in remotely to see what the performance is like and what you can kind of expect from a virtual desktop environment. As well as, I'd like to hear kind of more about your thoughts. If you've already looked at VMware View or Citrix Desktop, or maybe you've already done an implementation, I'd like to hear about your challenges and get some information and feedback on what you thought of this brief. So feel free to contact me, or if you want any more information about any of our products or where we're going in our direction, please contact me at my email address, gh@racktopsystems.com. It's been a pleasure, and I hope you enjoyed this brief.